Dear students, let's start lecture number 13 of the course Wireless Network. And today our topic is Wireless Access Point, means WAP or simply called AP or access point. And we will be discussing terms like BSS, BSSID, SSID, ESS, ESSID, and finally we will discuss association. So this is our outline. First, we will be discussing WLAN and WAP, wireless access point. Then we will discussing BSS and BSSID, SSID, ESS and ESSID. Then we will be looking into association, and in the association we will be discussing active scanning, passive scanning, and then we will be discussing reassociation and roaming, and then I'll give you an assignment, and then I'll share my resources which I have used in preparing these slide, and then we will have question and answer session. So let's start with WLAN and uh, wireless access point or WAP. So wireless LAN. Wireless LAN is a network where devices are using wireless to communicate. As its name indicates, wireless LAN, so definitely devices will be communicating wirelessly with each other in a defined area. So there will be a defined area from local area network. Like we will consider it example like home, schools, campus, or offline building. If you want to make a if you want to make a network of these, so you can call it as WLAN. It is most modern wireless LANs based on 80 or 802.11. This is normally IEEE. This is an IEEE standard, and it is marketed under Wi-Fi or wireless fidelity. Wireless LAN is ultimately connected to a wired network. Normally, it is considered that in wireless network we don't have any wires, but at the, you may call it, at the edges, you have only wireless, and above that you are connected through a network which is wired normally. A wireless access point, simply called access point or AP, is a device that accepts wireless signals from multiple devices, retransmit them to rest of the network. So what is the job of access point? So access point will be getting signals and retransmit it in a defined range for connecting different kind of devices. Now, WAP. Access points may also be known as base station. Access point at home often include routing function, thus may also be called as wireless router or wireless gateway in home settings. But in business level, APs and routers are separate devices in general. I'll discuss that while completing this slide. Access point is a layer 2 devices, because it acts like a bridge to connect two type of network, wireless and wired. As we discussed that access point or access point is where the access point is connecting. Actually, this is a bridge between wireless and wired. So above access point we have wired network, and below that access point, or where your actual devices are used, they are wireless, they are connected wirelessly. But these two networks are not separate. They belong to one broadcast domain. They belong to one local area network. So this is one local area network. Thus AP is just another layer 2 device, like a switch, handle, frames, and MAC addresses. So where the WAP or wireless access point is connected. Actually, above that you have a wide network, and below that you have the devices which are connected wirelessly. And we have one broadcast domain. Like for example, if you consider switch as a wireless access point is also a layer 2 device, and it acts same like a switch. Like all the switches of a switch, or all the ports on a switch, they are in one broadcast domain. Similarly, web is also a part of local area network, so it forms one broadcast domain. Now, come to BSS and BSSID. So BSS stands for Basic Service Set, is a group of wireless network device that are working with the same AP. So you may call it that if you take this as an example. So if the nodes are working with the range of this, so we call it as BS, Basic Service Set. And in a one service set we have a one AP normally. So basic service set identifier, or BSSID in short. So definitely you need identifier for the identification of one access point. So we call it as uh, um, basic services identifier, or ID. In AP's physical address or MAC address, which is 48-bit long hexadecimal number, like your computer MAC address. This is like of the same format, in the format like we have a MAC address of our NIC card. As a wireless user, you not see BSSID, but it includes in wireless package or frames. So here you can see that we have four different BSS, and each has its own BSSID for the identification. And in the each BSS, we have single access point exists. So here you can see that BSSID is MAC, one BSSID has an AP access point MAC address, or SSID, name of the network. Name of the network, this is used for identification. So now come to SSID. So service set identifier, sometimes called network name, is a unique character string used to identify an AP or a service set. You can see here in this example. Here, if you want to explore your wireless settings, so here you can see wireless network name, or SSID. This is unique in the network for identification. You can name it by any language. You can use any. You can give that that access point any name. As a user, you can only care about SSID. You select one from the list, from the list on your wireless devices, and use the network. Normally, when you want to connect a network, you need SSID. So normally, if you see, when you explore the network, you will find the list of the networks. So you will select one out of how many you are getting in your list. You select one for communication. For security of the network, you may be required to provide username and password. This is normally used for the security purposes. By default, an AP broadcast is SSID in its service area. So if you are getting the signals of that AP, or in other words, you can say that if you are in the range of that access point, so you get the signals of that AP, and you can get connected with that network, but you will have to provide your username and password to get the access to that network. Now, ESS and ESSID. It is the SSID broadcast that you the wireless network that are available. I have explained that. ESS and ESSID. One service area can be extended by adding more access points called an extended service set. Here you can see that we have this BSS and we have one BSS. So we have combined these two in one ESS. So we call it as extended service set. So each BSS has one access point. Here you can see, and each access point has its own uh, uh, address or a MAC address of 48 bit, like we have in a MAC address, you may call it. And this is BSSID address of another BSS. So though if we have combined these two, and we define single access extended service set. The shared network name is referred extended service set identifier, or ESSID, but there is formally no such thing as ESSID in 802.11 standard. As we mentioned that you will be, if you are on the device, you will be getting the network name, or if you are at the access point, you will be setting your MAC address. So you will not be defining any ESSID. You cannot see it physically. But as this is under the architecture of 802.11, so this is provided by default. Thus you can just use the same SSID or ESSID. In the extended service set, every AP broadcasts the same SSID to its user. As we defined that if you have the access point, if you have a SSID of single BSS, so you can move to another BSS easily. I'll define that in a while in my coming slides. So ESS and ESSID, when you as a user walk with your device from one service set to another, you are still connected to the same network without knowing you use a different service set and a different AP. For example, if you are here and you are moving to another BSS, so you will be remain connected. So this is, you may call it roaming subset subset A, and this is roaming subset B. So if you are here and uh, you move to another BSS, so you will be remain connected. And this is our overall structure of the network. Like you can see that you have a internet access here, then you have a router, switches, and in the switch you have, with the switch you have access point, and in the access point this has its BSS, and here access point B has this BSS. So if you moving from one AP to another, you will be remain connected with without knowing knowing different service set and different access points. You seamlessly remain connected. Now come to association. There are two type of association, like active scanning and passive scanning, and then re-association when a wireless devices is roaming from one BSS to another. Now first come to what is association. So wireless association means when wireless devices register with an AP or a router to gain a full access to wireless network. So this is called association. Association occurs only in infrastructure, but not in ad hoc network. As you know that in a wireless network are divided. Wireless networks are divided into two branches, like infrastructure based and infrastructure less based. So in association is normally occurred in infrastructure based, not in ad hoc networks. To establish the association, a wireless device uses of two methods to find access points. So there are two methods which are used for association to get connected with the network, to get the access of the network. Now the first one is active association. Wireless device broadcast a probe, a special type of frame to each channel in its frequency range and waits for an AP to respond. So in active, as the name indicates, active. So a normal a wireless device broadcast a probe or a special type of a frame and to each channel in its frequency range and waits for an AP to respond. An active scanning means the wireless device or a client initiate the search effort. So initialization of association will be done by the device in the network. Actually, it means that. Here you can see that. Let's see the process of scanning. So we skip the authentication and encryption, focus on active scanning as we are studying active scanning. So we have skipped the process of authentication and encryption. A wireless client sending a probe continually to scan for an AP. So if you have, as we have a device here, so device will be sending a probe to access point. You can see here. So both AP, for example, if the device in the range of these two subsets, so both will be receiving this probe request. So respond the sending their SSID. So what AP does that it will send the SSID to the device. The device sends a request for an association with AP might have stronger signal. So device might send the joining request to AP access point B. Might be this has a strong signal strength, and here you can see that device is not sending any confirmation or joining request to AP. So AP association with AP2 might have stronger signal, as I mentioned. AP2 respond with confirmation. So then this fourth one, AP or access point B is confirming approval of association. Wireless device can get the full access to the network via AP2. So now the device has full access to the access point, and from here it will be accessing the internet. Instead of using this path, it will be using this path because this device is in the range of this AP, and it is getting the stronger signals of this access point than this one. So here this is called active association. While in passive scanning, user device does not initiate the user device does not initiate the search efforts. As the name indicates, this is passive. So instead of this will be started by access points. So it simply sits back. Who will sit back? A device, and just listen on available channels within the frequency range for available access points. So it will be sit back and just here on the frequency channels in the range of access point. An access point broadcasts a beacon frame continually to its service area. This special frame beacon contains APs or access point information such as SSID, network name. Here you can see that this is an example that how it passive association is done. So here is the process of passive scanning. Skip authentication and encryption like we have skipped in active association. Both AP and AP1 and AP2 continually broadcast their beacons to all available channels within the frequency range in their service area. So access point will be sending sending beacons to all their channel in the frequency range. So AP will be sending in its own BSS, and this access point will be sending beacons to all channel with its own range. A beacon frame information such as SSID. So what that beacon frames contains, it will contains the information of the network. A wireless device listen on both the channels for the beacon, the device, and choose with the AP to associate with. So for example, if this is a device as this device in the range of both the access points, so it will be getting the beacons from both the access points. So it will again make a decision, make a decision on the basis of big signal strength. A wireless and listen on all channels. The devices choose AP to associate with. The time device select AP, it sends the request for its association with the AP. AP responds with the approval of. So once you can see here in this case, the device is connecting to AP1, because the signal strength of AP1 is greater than the access point of B. So then the access point will send the approval to get the device connected to the network. So this is how the passive association is done. So the basic difference between the active and passive association is that in active, initialization of association is done from a device, whereas in passive association, passive association, the process of association is started by the access point. So this is the main difference between these two. Now, reassociation and roaming. When it happens, if the wireless device moves from one AP to another, as we were talking, that you can seamlessly moving from one AP to another AP without without interruption of your communication. From one AP to another, extended server set, all the APs within the same extended service set would be the same SSID as a network name. To a mobile device, the network connection wouldn't be lost while it is moving from one BSS to another. The process of a device keeping the connection with different access point is called reassociation. So as you know that you will be moving from you will be moving from one BSS to another. So this means the extended service set comes into play, uh, uh, comes into play, and you will be connected to another access point without your knowledge. So same SSID will be used for connecting with another access point in extended service set. So this is reassociation and roaming. So your communication will not be interrupted while moving from one BSS to another in extended service set. Reassociation, this feature allows mobile device roaming. When you as a user walk your device from one service set to another, you wouldn't notice any different, even though you are using different APs. Both your device and AP work behind to make roaming possible. So your device and access point, they will be working behind without letting you know what is happening, what is happening in the background. So you will be get connected to another access point without your knowledge, and your communication will be done seamlessly. Now this is the assignment. You have to read and submit different variations available of wireless standard 802.11. So these are the sources which I have considered in making these slides. You can explore these sources to get more about this topic and learn more. If you have any question, you can ask me through KCMS or a group, WhatsApp group. I'll be more than happy to answer your question. With that, we reach the end of this lecture. So till next lecture, Allah Hafiz.